3,000. Label your sp3CHs to the right of 3,000. Label your OH stretch to the left.
Does this not have a CO bar?
That fingerprint region leads us astray. Let's just trust it unless we absolutely have to use it, like with an ether, like we had to use it.
There could be CO.
We only have
That's what I'm
IR.
saying, CO.
Now that we've got other spectra,
We're not looking
we're
at
going to ignore the fingerprint region
Because I mean, it
unless
doesn't,
we absolutely
it doesn't show
need
up.
it.
It
Okay,
doesn't show up.
so I'm already thinking there's an OH.
No, I'm saying like it's
I'm thinking with my mass spec, I've got to account for an oxygen.
Yeah, but
and I'm
it doesn't
thinking
matter because of that.
there may be an M-18 due to loss of water with an alcohol
Water.
in the mass spec. Okay?
18.
I gave you the spectra out of order
Tiny light.
here, but I strongly encourage you to go to the mass spec as your second option. So here we see a 70 is our highest peak. All right? And let's look at what we have here. So M-15, this is 55.
Do you know what
Biggest peak in the cluster here, 1, 2, that's 41, 42.
No, because in the last one you get 59.
It's even. It's a major fragment. I'm going to circle it.
I think there's a lot of 71.
41, 42.
Oh, okay.
If 70 is my molecular ion, 55 would be M-15. 42 would be M-28. That makes me think McClafferty. So I'm kind of, at this point, I'm thinking, what's going on? Right? Well, luckily, you've got a carbon NMR that can help you here. How many carbons does this have? Well, 70 divided by 13 suggests 5 are possible. Let's look at the carbon NMR. We've got 1, 2, 3, 4 carbon signals. 1, 2, 3, and 4 carbon signals. There are at least 4 carbons in the molecular formula. There could be more if there's symmetry. Okay, there could be more, but not more than what we think with our molecular ion here. Let's go to the hydrogen NMR. Okay, A, B, C, D, and E. Look at that. 6 plus 2 is 8, plus 1 is 9, plus 3 is 12. Whatever my molecular formula is, it better have 12 hydrogens accounted for. Because the integration doesn't lie here. Symmetry or no symmetry, I've got 12 hydrogens in my molecular formula. Oh, and look, there's that OH, that broad singlet. A broad singlet is right there. It's what it looks like in the spectrum. Okay, so double evidence for the OH. Again, 1, 2, 3, 4 signals.
Okay. If there's symmetry in the compound,
where carbons are.
sides that are like symmetrical,
Look at this 6 hydrogens, so
or
our
combine
alkyl
into
region.
essentially like the same hydrogen, like when you rotate it.
Why did I move on from the mass spec? Because I got some confusing fragments and I wasn't quite sure. So I went on to the NMR to see if I could find some more evidence. There's no such thing as a CH6 group. So that has to be 2 equivalent CH3s. Two equivalent CH3s. And then a CH2. And then a CH. Look, another CH2. Then an OH. So 1, 2, 3, 4, 5. I do have 5 carbons in in my spectrum. There is some symmetry there because I've got two equivalent CH3s. There is some symmetry because of those 6 hydrogens that split into a doublet. That's a clear sign of an iso feature in my spectrum. A doublet means there's one neighbor, 2 CH3s with one neighbor. That's exactly what we've got here is an iso group. So there is some symmetry. There are 5 carbons in my spectrum. So at this point, I'm going to come back to the mass spec and say C5H12O and see if that gives me something reasonable.
He did 70 divided by 13.
I got the C5 from the NMR.
Yeah.
I got the H12 from the NMR. I got the O from the IR. Let's see if it makes sense. So I'm going to say 5 times 12 is 60 plus 16 plus 12. That's 88. That makes this M minus 18, loss of water.
Oh.
Our degrees of unsaturation,
Wait, where did I get 88 from?
1 plus
When you add
5.
them all together.
Oxygen drops out, minus 12 over 2. 6 minus 6 is 0 degrees. That matches my IR
Shouldn't there be? Oh no, no. There shouldn't
and my
be
NMR.
88. That's what
I don't see any evidence of benzene in the NMR. I don't see any evidence of a double bond because of chemical shift. I don't see any evidence in the IR of either of those
You don't
things
start
either.
pricing N, you start pricing N minus. Yeah. So there should have been a peak at 88 then. So there
Yes.
should have been a peak at 88. Yeah, that would be the whole thing.
Subtract the oxygen.
Yeah, there should
We did it in reverse order by using the NMR to help us. So we found the molecular formula, added it all up, and then checked to see if it worked.
So what?
I knew I had 5 carbons. Good question. I knew I had 5 carbons because of my NMR. The carbon NMR told me I at least had 4 because I had 4 different signals. Then my hydrogen NMR told me that I had
molecular ion
equivalent
is just invisible.
CH2s.
Yeah.
How is it
Okay, so
supposed to
we're not crazy, right? There
No.
should have been a peak there.
Using the
No,
splitting,
he said it might not show up every time.
Well,
How are you supposed to know that?
All right, we'll continue on Wednesday with practice.
But on Earth.